Okay, so hello and welcome everyone to this webinar hosted by Ipieca-IOGP. Today's session is also supported by the Oil and Gas Decarbonisation Charter, so OGDC. My name is McCusker. I'm a Climate and Energy Manager here at Ipieca, so I'll be helping to facilitate today. But yeah, today we're here to provide an overview of the now updated Ipieca-IOGP Energy Efficiency Compendium. So this resource covers 25 different technologies and practices that companies can readily use to enhance energy efficiency. We'll also have 2 case studies just showcasing how industry members are already using this resource to make improvements within their operations. So essentially, yeah, we'll have 3 main presentations today, after which we'll then commence with a Q&A. Just before we start, just wanted to cover a few minor housekeeping items. So this session is being held on Microsoft Teams, their webinar function. So it's largely similar to a standard Teams call. But in terms of submitting questions, you'll see a Q&A button on the top banner of your screen. So feel free to submit questions there as we go. For all other inquiries, you can use the chat box as well. And then finally, just wanted to say that a recording and slides will be shared after the session via email. So just keep an eye out for those. Okay, I'd just like to say a few brief words about Ipieca for those of you who aren't familiar. So Ipieca is the global non-lobby oil and gas association dedicated to advancing environmental and social performance across the energy transition. We were formed just over 50 years ago, back in 1974, at the request of UNEP to be the principal channel of communication between the industry and the United Nations. We're a member-led association, so our members all get a real chance to direct and govern all of the work that we do, and we also cover the full oil and gas value chain. Here you can see the 3 pillars that we cover at Ipieca, so climate, nature, and people. I think generally speaking, within climate, we're working to advance the industry's contribution to a net zero future. Within nature, I think the focus is on better managing industry's impact on the environment through restorative approaches and supporting the circular economy. And then within people, we focus on improving social performance within the industry, so including things like respect for human rights and contributing to social and economic development. And in terms of how we action all of this, so a key focus is on actually developing and sharing best practice and guidance. So the Energy Efficiency Compendium that we're here to talk about today is a great example of that. There's also a strong focus on convening industry members to learn from one another, so through peer sharings and workshops, and then also engaging with experts and external stakeholders too, just to exchange expertise and learnings. So yeah, right across Ipieca, I think there's a lot of collaboration and shared learnings. But with that, I'd like to now pass to Dario Buccellato. So he's the Energy Transition Manager at IOGP, just to give you a brief introduction of IOGP too. So yeah, Dario, over to you.
Thank you, Jack. Good morning and good afternoon, everyone. Okay, let me take control. And so a few words about IOGP. IOGP, similar to Ipieca, is a member-led organization. We have a bit less than 100 companies, 100 members, most of which are oil and gas upstream operators that you see on the slide on the left-hand side. And we focus on a number of topics from a purely technical perspective. So HSE, so safety, environment, standards, engineering, digital solution. But we also have a strong focus on energy transition. And that's, in a way, the topic of today. Part of it is energy efficiency. So what we have done in IOGP is our members came together in 2020 to do a strategy review, during which they have assessed the needs for the industry to have more support on the energy transition journey that they were all embarking. And there were a sort of interest to develop some specific technical focus to support the industry. So a plan has been put together that has been developed in the past 5 years around 5 main streams or topics areas. One is, of course, energy efficiency, today's topic, flare and vent, methane emission management, carbon capture, transportation and storage, and electrification of assets. So during the past 5 years, a number of technical documents, guidelines, recommended practice, or technical solutions have been developed or shared by the members, put together in a number of documents that are available through the IGP library that can support the decarbonization journey of the oil and gas operators with a specific focus on Scope 1 and Scope 2 emissions. Now, all this, give me a second. Okay, all this has been put together in an holistic tool, what we call the Energy Transition Integrated Framework, which is the tool that you can access if you scan the QR code on the right-hand side of the slide that summarize all those technical publications, including the energy efficiency topics that we are going to discuss today, all in one place. So any company can take the solution that the best fits the specific needs, combine them, choosing from the different colored boxes that you see on the screen, if it's methane, if it's flaring, or if it's energy efficiency, and build up your energy transition pathway towards the decarbonization. So energy efficiency is a key topic, is available there, is one of our pillars. I don't want to take too much of the rest of the time and give the mic to Nelson, who will start digging into the details of energy efficiency before, as Jack has anticipated, we will move into case studies. Nelson, the mic is yours.
Hey, good afternoon all, and good morning, depending on which part of the world you are. Just take control of the presentation. Okay, so I'm one of the co-chairs of the Energy Efficiency Experts Group in IOGP, and I work for Azule Energy as a facility engineer for Ngoma FPSO in Angola. So I'll tell you about the Ipieca-IOGP Compendium of Energy and GHG Efficiency Technologies and Practice. So the agenda is going to be, so basically I'll briefly, just over in about 6 minutes, I'll tell you about the importance of energy efficiency, the objective of the compendium, the scope of the compendium, example info sheet, and a summary. So in terms of importance of energy efficiency, as many of us know, so enhancing energy efficiency supports organization in 3 main areas, which is greenhouse gas reduction, cost savings, and regulatory and standard compliance or decarbonization emissions. So contrary to what many companies think, so energy efficiency can be a low-cost decarbonization level, really. And the International Energy Agency analysis has indicated that energy efficiency could deliver significant emissions reduction to achieve the Paris Agreement goals. So therefore, it's quite important that we keep on pushing on every organization, an oil and gas organization, energy efficiency. So objective of the compendium. So the compendium was finalized in partnership with the IOGP, so between Ipieca and IOGP in June this year. So the compendium basically entails the introduction to energy efficiency for oil and gas facilities, practical examples, case studies, business case for adopting technologies and practices. So it is important to mention that these are not speculative technologies. These are proven technologies, and they are real-life examples in this compendium. So, and the key objective is to encourage the adoption of the energy efficiency technologies and practice across the oil and gas industry. Now, the compendium entails several technologies. There's a full range of technologies, about 25 technologies, mainly for midstream and downstream, but there are also several, about 12 technologies for upstream. And on the slide here, we put the a QR code where people can go and scan with their computer, with their smartphones, and we'll take them directly to the compendium. They will find all the technologies, and they can filter by category and also by sector, like upstream, downstream, and midstream. So, and also for each of these technologies, people will find info sheets which have very particular structure. So all the info sheets, they have the same structure, so that then it's easy for people to compare the different technologies. Now, so the info sheets, the information they have is the technology review, the application in the industry, energy and greenhouse gas benefits, business case, implementation considerations, performance metric, and case studies. So take it as an example, one of the latest technologies that was included in the compendium, which is the battery energy storage system. So for this one, we have a technology overview, which it doesn't go way too technical, but simple enough for most of the engineers to understand. And also we have failure in the deployment of the technology, data statistics, which help people know how well or the failure rates that companies implemented had when they are adopted this technology. So we can see from if we look at the orange line, we can see from 2018 to 2020. So there was a sharp decrease in the failure rate of this technology, and in 2023 it's almost going down to zero. And from 2018, at the adoption of this technology start, we can see from 2018 to 2023, there was an exponential increase in the adoption of this technology. So another thing that we can find in the info sheet is also decision drivers, which are technical, operational, commercial, and environmental. So this helps organizations make their decision around the use of this technology. So in summary, so energy efficiency can be a low-cost way to reduce operational emissions companies, and there are benefits in improving energy efficiency. And with this compendium, so which works as a hub for all these technologies, which usually are difficult to find elsewhere. And when we find these technologies, sometimes it's not free of charge, but with this Ipieca and IOGP compendium, so all these technologies are available in a single place, free of charge for companies to directly implement across their operations, right? And start to reduce their emissions. So what we wish is to have a very large scale implementation across the oil and gas industry, this energy efficiency technologies, but it is a challenge, and therefore collaboration is required to enhance the uptake of energy efficiency solutions globally. And that's the reason why we have webinars like this, so that we can raise awareness of people to start these technologies across the operations.
Okay, so good afternoon, everybody. So I introduce myself. I'm Federico Bruschetta, engineering manager in Azule Energy, based in Angola, and I was involved in Agogo FPSO project, and today I'm going to present and introduce you this case study about Agogo FPSO and all the initiatives that have been implemented in this project to optimize and to improve the energy efficiency of this offshore project. So I will go, this is a summary through a quick introduction to this project. I will then introduce yourself the main initiative that have been implemented for GHG saving, and then in the last part of the presentation, I will focus more on 3 initiatives that I think it is worth to introduce and to present in order, because are the main important one in terms of energy efficiency, and also are the most innovative one implemented this project. So first of all, as I said, Agogo FPSO is an FPSO that is installed offshore in Angola in a water depth of about 1,600 meters, and is a spread moored FPSO taken from a existing tanker. So this is a conversion project. The maximum oil storage capacity of Agogo is 1.6 million barrels of oil, and the nameplate capacity for the oil production is 120,000 barrels of oil per day. So this is now live. So actually this project had the first oil just last July, and now is in operation. So I want to point out that since the beginning of the engineering and already during the concept selection, a lot of effort has been put in place in order to identify what we call BAT, so the best available technology, to be introduced in the project in order to allow us as a corporate, as Azule, to improve as much as possible our footprint and reduce as much as possible the GHG emission for our project. So a study has been put in place, and overall has been identified 13 initiatives that you can see presented in this slide that finally has been introduced in the project. So some of these initiatives, this is a very important concept, are really a sort of first of a kind, like the introduction of a pilot plan for CCUS, the installation of seawater recovery turbine, or the installation of combined cycle, even if actually there are 2 additional applications on FPSO. But on the other side, we have also tried to implement as much as possible technology that somehow are innovative, but are also well proven, like vapor recovery unit, the use of VFD, the use of oil compressor with majority with electric motor, and so on. So there is this mix, this combination between well-proven technology and innovative solution that guarantee us the possibility to reduce the GHG emission of about 27% compared to FPSO without this kind of technology installed on board. I want to also to stress that the main contributor in terms of GHG saving for our project was the power generation. So of this 27% reduction, 16% was due only to the fact that we installed the combined cycle instead of a traditional open cycle for power generation. And this allows us to improve a lot our energy efficiency. Of course, everybody of us is aware on FPSO, usually the main contributor in terms of CO2 emission is the power gen. So having installed a very efficient power generation gave us the possibility to bring down this important indicator. As I said, today I'm trying to go much more in detail on 3 initiatives that are the combined cycle, as I said before, the carbon capture and the seawater recovery turbine. Reason why we selected these 3 among all the 13 is, so for sure, the combined cycle, as I said, is the most important one in terms of reduction of the emission. So I think it is worth to spend time on this. The other 2, the seawater recovery turbine and the carbon capture, represent the first application on a FPSO. So it is the first time that such a kind of technology are introduced in an FPSO project. So regarding the combined cycle, basically a combined cycle is just a improvement of what is the typical open cycle. So in the open cycle, we use can be dual fuel. So usually we use or diesel, or when is available, the fuel gas, and we generate power with a gas turbine. The part of fuel gas, the energy that is not transformed into power, is dissipated into heat, and typically there are installed waste heat recovery unit where you recover and you regenerate, you use this heat to recover the heating medium for the process. In the combined cycle, instead, the principle is more or less the same, but then you combine the gas turbine with a steam turbine generator. So basically, part of the heat that is dissipated from the gas turbine is used to generate steam, and this steam activates a steam generator that produce additional power. So with the same amount, more or less, of energy, you are able to improve much more the efficiency. So, I mean, an open cycle typically has an efficiency of about 30%. With a combined cycle, in optimal condition, you can reach also 50%. This solution, as we said before, reduce the total GHG emission on a go-go of about 16%. Going more in detail, on the FPSO, we installed 4 gas turbines, 4 GTG, with a rating capacity of about 30 megawatt, plus 1 steam turbine with a rating capacity of about 25 megawatt. For the design case, basically we have 1 spare, so the configuration is of 3 GTG running plus 1 STG. Here we saw a simple presentation where we can see how is figured out the module. As you see, in each module we have 2 GTG, and then there is an additional module where is installed the steam turbine. So actually the principle is quite simple, as explained before. So basically from the exhaust of the gas turbine, the heat inside the gas turbine is used is recovered to generate steam, then activate the steam turbine. And move. Okay, so the second initiative that I'm going to talk about is this CCUS plant, so carbon capture unit storage. So this is a technology where basically we use the amine in order to capture the CO2 that then is reinjected into the reservoir. I want to stress the fact that this was like a pilot plan. So this has been installed not really for energy efficiency, because the amount of CO2 that we are able to absorb is quite limited. But the main purpose of this pilot plan was to test the absorption in offshore environment in marine application. And as I said before, this was the first application of this kind of technology. So the principle is quite simple. So basically the fuel gas is spilled from the HSRG, that is the heat recovery steam generator that is installed on top of the gas turbine. So basically this fuel gas is then cooled up to 50 degrees, and then there are two absorption columns where, with the use of this solvent that is amine, the CO2 is captured. So the CO2 is captured by the amine. The gas is then released to the atmosphere. Instead, the amine that after the absorption is rich of CO2 need to be regenerated, and then the CO2 is injected through the MP compressor of the FPSO to the reservoir. You can see also a picture in the center of the slide. This is how it shows this skid. So in order to allow easy installation and easy integration that is quite complex in an FPSO, we design this modularized concept. So we present these two columns, quite small and quite tall, and we designed them in order to fit with the limited available space. As I said at the beginning, the absorbed CO2 is about 0.3% of the total CO2 produced by the plant. So again, the value is not really big, but it was important to introduce this pilot plan for testing purpose. Slide, we want just to introduce a challenge that we face during the design, because actually the concentration of the CO2 in the exhaust of the GTG is quite small. So this led to an increase of the absorption column. So if we see, for example, the graph on the bottom left, we can see that in case you have a concentration of about 6%, we can consider an height equal to, let's assume as a reference, 1. Reducing from 6% to 3% the concentration, that was actually our case, the height of the absorption column increase of about 30%. Due to this problem, and due to the fact also that there are some sloshing effect due to the motion of the FPSO, was necessary to split the column into two. So instead of having one single column of more than 40 meters, we provided two different columns of 22 meters each. As explained before, the plant has been designed in two skids also for easy installation and integration. The last technology that also in this case was the first application provided by our supplier, in this case was Framo, was the installation of a seawater recovery turbine that is installed into the sea at a water depth of 11 meters from the sea level. So I don't know if everybody is aware, but so typically in all FPSO project is typical to have for cooling, for process cooling, you take the seawater from the seawater lift pump. In this case, the mechanism is exactly the opposite. So we use the energy from the discharge water that is transferred into electric power with the activation of this turbine. So basically, instead to waste the energy, we use the discharge water in order to recover electricity, electric power, and with this technology, we are able to recover about 25% of the energy that is steady used to produce the seawater that is necessary for the cooling of the process on top side. So with this technology, basically, we are able to recover 1.3 megawatt. And again, this was also a first application that have never been installed before Agogo on other vessel. So as conclusion, what we can say is that, of course, in the oil and gas market is increasing the attention in order to have better result in terms of energy efficiency, to have a plant that are able to have a less footprint. And so it is fundamental when we start a project to make a very deep analysis to understand which can be the best available technology to be put in place in each project. It is also important that is not so the best available technology are not valid for all the project. So it really depends on the kind of project, and it is important also to say that this decision must be done based on a cost-benefit approach. So each project is specific, has different budget, has different solution, has different production profile. So according to all these input, it is important to identify the best approach. So we did this exercise on Agogo, and we can say that at the moment Agogo represent really a benchmark in terms of energy efficiency for the oil and gas market. So thank you everybody, and I'm available for question if any. Thank you.
Yeah, thanks all for those really interesting presentations. So appreciate the insights from Federico, Nelson, and Andy as well. So yeah, I think we've got 11 minutes now for Q&A. So for this part of the call, I'd like to introduce our moderator. So today it's Antonio Lopez-Rodriguez. So he's the head of energy transition and climate change at Repsol. And he's also the vice chair here at Ipieca for our climate change group. So just a quick last reminder, if you do have a question, so today the mic's been disabled for attendees. So if you do have a question, please put those in the Q&A function. Thank you. So Antonio, handing over to you.
Yeah, thank you, Jack, for your introduction, and thank you all the speakers for the very clear explanations and very clear presentations. Maybe we have two questions. We can take the Q&A chat, but maybe we have two questions in the audience. So Jack, if you don't mind, we can give the floor to Jim in the first time. Jim Herberson.
We sadly for this session we've disabled the microphone for.
Okay, so sorry for that. These two hand raise, they need to put the questions in the Q&A chat. So I'm very sorry for that. Yes. So so let's take the questions. No, I have one for Andy in the chat. I tried to find it. Yeah, it's regarding the use of, you use the tool to calculate the gap based on equipment benchmark, but the question is, where is the benchmark being sourced from? I mean, you compare, but how do you produce this benchmark, and where is the benchmark being sourced from?
Yeah, thank you. I've also replied in the chat, but I'll answer it now as well. So we have different targets for both GAP 1s and GAP 2s. For GAP 1s, which is more around, if you remember what I said was around maintenance and also equipment improvement, that's generally based on historical targets. So we look at historical data and we maybe look at, for example, the 90th percentile or 10th percentile target for that. GAP 2s is very different. So for GAP 2s, we're looking at how do we improve the efficiency of a particular item of equipment? So that's from our own internal benchmark. So we have a global energy management system at ExxonMobil, and within that energy management system, we do have benchmark targets for different items of equipment. So that's where that is from.
Okay, thank you. I have another question for Federico. The question for Federico, well, there are two. One is in the preparation of the analysis of the different initiatives, out of the 13 initiatives, do you only execute 3, or maybe you execute more? And how do you develop rankings for this initiative for prioritization?
Okay, so no, the 13 initiative that we have, I have presented in the slide, all has been at the end implemented on our project. So all 13 has been implemented. The one that we presented are the one that at the end we think are it is worth to bring to the attention of everybody because are not really common application. Again, there are some others, like for example, the installation of LED light that of course are improving the energy efficiency, but I would say are also now a common and typical solution in also other vessels. So are not really are of course innovative, but not so much. So, but yes, all the 13 initiative that is being identified in this slide, and you can also find in the slide pack, has been then put in place and implemented.
Okay, thank you. I have another question for you, Federico. What is this is a question related to the pilot plan you mentioned, the CCUS. What is the capture cost? Well, I suppose, and how do you create the business case to justify this pilot plan in the FFCO? So I suppose it's more in the way of research and understanding.
Correct.
But you can answer
so
that.
Actually, yes, you are completely right in the sense that this pilot plan has not been installed on a basis of cost. So the basic decision making was not based on cost, but was installed as a research program. So actually, I have to say also that Agogo basically is an operated project. So there was our main contractor that also put a lot of attention to this topic. So bring this possibility to us to cooperate in introducing this specific technology, and we decide to install that. So again, was not based neither, so we didn't install this nor for reduction of CO2, and also was based on not on cost assumption. So this is the truth.
Another question from my side. Well, the CO2 that you reinject in the reservoir is for enhanced oil recovery, or is a permanent storage?
No, permanent storage.
Okay. I have another question, Federico, for you. It's
yes.
Did you have many challenges related to commissioning and startup the steam cycle?
I can say, of course, yes, it's more challenge respect to a normal pen cycle. In any case, we perform full commissioning of the steam turbine already on shore. So before leaving the shipyard, that in our case was in China. So I would say yes, more complicated, but was not a showstopper. So we were able to fully commission it. The only point is that in order to commission this steam turbine, you need to have online minimum 2 GTG. So, okay, it was not really easy. And then, of course, there are some procedure related to the fact that the steam line must be very clean, so you need to ensure proper cleaning of this steam line. So yes, I would say the commissioning part is more complex for sure, more longer for sure, but in our case was not a showstopper. So of course we need to proper plan, but was done already again before even the sail away of the vessel.
Okay, I have another question for the Nelson from IOGP. Well, it's regarding the the question is how many developers did it take to develop the tool, and how many does it take to maintain? For Nelson or other IOGP people that are in the call.
Or is it about the IGP tool, or is it about the ExxonMobil tool? I'm not sure.
No, I mean the tool is the energy efficiency compendia, and yeah.
Oh, okay, well,
yeah.
To develop the compendium, we initiated in 2022, and the last document has been completed recently. Of course, we had to take into account the effort done by a number of subject matter experts involved. So we took a few years to make sure that we were addressing all the solution in a proper way. In terms of numbers, I do not have a fixed number because many experts have given their own contribution based on their company experience on the different solution. So, but it has been an effort. I think usually during the expert group meeting, we had more than 20 plus people involved sharing their own experience.
Yeah, and you give me the opportunity to also translate the same question to Andy, because you show a very holistic tool covering all the different equipment related to energy equipment, and I suppose that your answers could be, well, it depends on the system, but in your case, how many engineers are involved in this development? I suppose many of them, but.
Yeah, I mean, it was a handful of engineers required for the development of the tool. Sustainment phase, less engineers than in development phase. But what you've got to consider is you also need support from the sites as well to provide the information and to review the tool as well, and also need some IT support as well.
Yeah, thank you. Well, I don't know. Maybe the last question, Jack.
Yeah, one more quick question.
Yeah, we can go for another question also. Well, regarding the compendia, no, is there is a question regarding about if we can express the payback times on some of the technologies and if they end up adding value, no, in that cases.
Yeah, maybe I can take that one. I've written a written response there, but I think for not all of the fact sheets in there, there's an explicit payback time, but for some there are examples and case studies where there are. I think, yeah, mostly it does also recommend to sort of do like a life cycle cost analysis, because, you know, I think payback time depends heavily on sort of the specifics of the site, fuel price, what kind of fuel it's using, operating hours, etc. So there is information generally around that, and then within some of the fact sheets, there's actually quite detailed information as well.
It's very clear. But it's very clear that the energy is a very quite important, but also CO2 in some regions can move also the opportunity, you know. So yeah.
If I may also add, when the group discussed the different solutions, I mean, a solution can give value and added value to the asset, but I think a specific analysis on the asset application has to be done to make sure that the cost and benefit analysis is tailored on the specific case. So even if there is an example of a similar project, I mean, whatever Federico's done in the Agogo project might apply or might not apply to another FPSO, depending on the condition of that FPSO. So things have to be tailored based on the specific asset.
Yeah. There are many other questions in the chat, but maybe we can answer offline with we can send it to the specific speaker and try to answer. No, I don't know what is the Jack.
Yeah, I think that works. Just to respect people's time, I think that's the best approach here.
Okay.
But yeah, well, I think we're a minute over already. But yeah, I'll just close by saying thanks again to all our speakers today. Thanks, Antonio, for moderating, and also thanks everyone on the line for your participation and questions. Yeah, it's good to see that many people join these sessions. So as mentioned earlier, we will share a recording and slides. So just keep an eye out for that email. That'll be coming soon. But yeah, with that, just say thanks and have a great rest of the week.
Thanks a lot.
Cheers. Bye-bye.
Thank you. Bye.
Bye-bye. Thank you.